Hello. This video is for anyone that has a little bit of trouble factoring still and just needs a little more help. So I'm going to take a look at another factoring problem, but do it in a little different way than normal. So let's take a look at x squared plus 2x plus 1. Now, often teachers will start off by saying we want two numbers that multiply to give you 1 and add to give you 2. And for some students, they don't understand where that comes from. So let's take a look at that. Let's understand why are we looking for two numbers that multiply to give you a 1 and add to give you a 2. So to start with, we know the answer looks like this, right? It's going to be something times something else. And we also know that you start off with an x and an x. You always do that. So let's just pretend for a moment that we don't know how to get the rest. And let's just guess, a completely random guess. I'm going to say x plus 2 and x plus 1. I know that's not right. But for now, let's see what happens. Because how do I know that's not right? To do that, we'd need to FOIL it out. So I'm going to take and multiply, if you don't know FOIL, that's F-O-I-L. Stands for first, outside, inside, last. So I'm going to multiply the first terms of each, which is x times x, which is x squared. The outside terms is x and 1. So x times 1 is x. And then the inside terms are 2 and x, because they're in the middle. So 2 times x is 2x. And the last terms, well, that's just the very end of each part, is 2 times 1 is 2. At this point, we need to simplify. So we need to combine like terms. So we have an x squared term, we have an x term, we have a 2x term, and we have a constant, or just no x term. So the like terms are going to be the x terms. So we have 1 of them plus 2 of them gives me 3 of them. And that's as simplified as we can get. And so we look at this final answer here and we say, is that the same as the original? If it's the same, then that was our answer, and this original solution that we came up with would have been right. But obviously it's not the same. So if we're going to go with the guess and check approach, we'll go back and try another guess. But why don't we take a little bit closer of a look and see where all these numbers came from? So first off, let's look at this 2. Where did it come from? Well, it came from this 2. Where did that 2 come from? It came from multiplying these two numbers. We multiplied 2 times 1 to get this number. And so that's why we often will say we're looking for two numbers that multiply to give you this. Because when we do that in our guess, that's what we're going to get. So at this point, we know now that in order to get this last number a 1, we have to use a 1 and a 1, because those are the only ways you can multiply to give you a 1. If that number were, say, a 6, we'd have multiple choices. Because for 6, you can either use 1 and 6 or 3 and 2. But here it's easy, so it's just 1 and 1. So at this point, we can just say our answer has to be x plus 1 and x plus 1. I didn't even use that 2, because if it was anything else, we couldn't do it. Unless it was a negative 2. Because if I made both of these numbers negative, negative 1 times negative 1 is a way to get 1. And so x squared minus 2x plus 1 is still factorable. Let's look at another example that will make it a little more important that we look at this middle term. And also, another thing that throws people is negatives. So we'll make sure that the next example has a negative in it. Let's look at x squared minus x minus 6. Now, if we're going to do that, the guess and check approach, we would say, okay, with the double bubble, we know there's an x here, and we know there's an x here. And if we don't have any other idea how to factor, we would just say, well, how about we do minus 2 and plus, how about 2? Completely wrong guess. But I'm just going to show you how we would find out it's not right. So then we FOIL. So just like before, first outside, inside, last. So x times x gives me x squared plus, now we have a 2x, and then a minus 2x, and a minus 4. And now we have x squared plus 2 minus 2 is 0x. Let me get that better. So I wrote that 0 for a reason. Normally you would just say this is x squared minus 4. But I wanted to emphasize the fact that that is a 0 there. So if we look at this and say, is that the same as the original? Obviously it's not. And how did we get this 4? It's actually a negative 4. Well, we multiplied negative 2 times positive 2 to give me that negative 4. So if we wanted to do this correctly, we need to find a way to make these two numbers, instead of 2 and negative 2, they need to multiply to give you negative 6. So let's think about the ways you can get a 6. I can be 1 and 6, or it can be 2 and 3. Those are the only options. And so I now know that these two numbers I put in there have to be 1 and 6 or 2 and 3. I don't know which one, and I don't know whether they're positive or negative at this point. But what I do know is, am I looking for actually positive 6 or am I looking for negative 6? I like to ignore that negative up until this point, because it's easier for me to think of the factors of 6 than the factors of negative 6. But at this point, we better consider it. And what we need to do is consider what is going to happen with this middle term. In this case, we want it to be negative 1. Well, in our example that we guessed at, we got 0. And where did that come from? We took 2 minus 2. Or we could have looked at that as 2 plus negative 2. So this one is negative 2 and this one's positive 2. And so when we added those together, that gave us 0, right? Well, we didn't want 0. We wanted negative 1. So whatever we choose, when we add them up, well, we want it to add up to a middle term, which is negative 1. So that tells me what the answer is. Because I know that 1 and 6, is there any way I can add or subtract those to get a 1? Because I could, if I made them all positive, I could add them and get a 7. But I don't want 1. I don't want 7, I want a 1. Negative 1 specifically. If I make them both negative, I can get a negative 7. If I make one of them positive, I can get 5 or negative. Or if I make one of them negative, I can get 5 or negative 5, but never negative 1. So it's got to be 2 and 3. And so then now the only question is, I need to get a negative. So one of them has to be negative, but which one? Well, try it. If I say negative 2 plus 3, oops, didn't mean an x there. I just mean negative 2 plus 3. If I make the 2 negative, that's what I get. I'm going to get a positive 1. Is that what I want? No, I want negative 1. If I do 2 minus 3, that's the other option, now I get negative 1. So my answer here is 2 and negative 3. Once I have that, everything's easy. I just put my x's there. This always starts off the same way when you're doing this double bubble method. And now I have a 2, which is positive. So I say x plus 2. And then I say x minus 3. And that's our answer. So just to remind us, the method that you're told, that hopefully you have a little more understanding of, is it says we want to find two numbers that multiply to give you this -6, which is what we did here. We found two numbers that multiply to give you -6, and they have to add to give you this -1. One quick question I have to think about is, why did I put x plus 2 first? Could I have done x minus 3 first and made this my answer? Think about that for just a sec. Would that have been okay, or would that be wrong? And the answer is that would be fine, because multiplication, order doesn't matter. So it doesn't matter which one you get, x plus 2 times x minus 3, or x minus 3 times x plus 2 is your answer. So hopefully that helped explain a little more. If you still have problems, I'll have other videos up to help out. Thank you.